So now I'm going to do a little differentiation, differentiate functions. We're going to use the power rule quite a bit, in fact, all the way through. And that's, again, d dx of x to the n power is equivalent to n times x and reduce the power by 1. All right? So that's going to be our baseline for all of these. So the first one, and remember, coefficients have little play in there. If I have a coefficient c on this, I should put that in there. I'll do it in a different color in red. If I put a c here, it's just c times n. All right? It's not going to change the power rule at all. All right, with that said, I'll save that and put it up here. You'll see I have a coefficient of 5, t raised to the negative 3/5 power. I don't care about that. So it's negative 3/5 times the 5, bring the power down, and then reduce the power by 1. Negative 3/5 minus 5. So I show r of t here in black. R prime of t is negative 3 times t to the negative 8/5. And again, that is because, and again, it might very well show it this way also, the 5th root of t to the 8th. Both of these are equivalent. All right, depends if you leave it in fractional exponents or radical notation. All right, 12, and I'm going to do 10, 12, 14, 16, 18. Now, everybody, you could do the quotient rule if you want to be abusive to yourself. The better thing is to catch that r of x is one term and bring up x to the 7th and make it negative, right? It's one of our things. Now it's again, same thing, c times x to a power. Bring the power down times c. Reduce the power by 1. And I have just found the derivative. And if you want to write it with a positive exponent, we get that. Now often I have students who do the quotient rule with this. It will work. Again, I'll do it in a different color quite quickly. The derivative of 10 is, square root of 10 is 0. X to the 7th to the 2nd power, 7 to the 2 is 14. But you got to do a lot of simplifying with this, and it's a lot more work. But you guys will see the green here becomes the red on for that rule. All right, so again, we just did 12. We've already done 10. My phone just dinged, telling me it's probably trying to go home. Again, number one thing with 14 is not to do the quotient rule in the second term. Our first thing is to write this in fractional exponents. And everybody, we want to bring the square root of t to the top, and 1 times it's still that. And then this derivative is so simple. Bring the power down, reduce the power by 1. Negative times a negative is half t, and then reduce the power by 1. Everybody, that is the answer to number 14. All right, number 16. Oh, again, just write this as fractional notation first. And again, bring the power down, reduce the power by 1. All right, and realize, again, I keep doing this rather quickly, but this is old skills for us. We should see that these are the same. Last one today, 18. Again, a quick feel for these. This one got quite a few students when I assigned it in the past. We ought to see it's coefficient times u plus square root of 3u. I do not want you to do the chain rule here. We want to use our rules of radicals. Square root of 2 times u plus square root of 3 times square root of u. So g to the u is square root of 2, u to the 1 power, plus square root of 3, u to the half. And now we'll use the power rule on two independent terms. G prime of u is just square root of 2, right? Plus, bring the half down, square root of 3 over 2, reduce the power by 1. And I would take this answer, if you want to put it back in radical notation, it would look like that. Again, this comes to practice. You got to work the odds on both sides. Let's be clear, this is quite a bit of work. All right, and I minimize 1. So keep grinding, keep practicing. Look for shortcuts to use the power rule.